Have you ever wondered how triglycerides are formed? They're basically just the normal lipids formed of carbon, hydrogen, and oxygen elements, where there are ester linkages that bond the fatty acids and glycerol. Of course, we're gonna know further information about fatty acids. There are the saturated ones and the unsaturated. Okay, but from now on, we're gonna learn how the triglycerides are formed. They are formed from glycerol and fatty acids. Where they are nonpolar, they cannot form hydrogen bonds with water, as they do not contain the OH inside them. We're gonna now know the structure. Well, we just said that it is about glycerol and fatty acids. How do we possibly draw the glycerol structure? Well, the glycerol is just an alcohol type where it has OH inside them. 1, 2, and 3 carbons, and at each one of these carbons there is an OH molecule here and H atoms right here. That's the glycerol structure, plus the fatty acids. Well, the fatty acids have a hydrophobic head and 3 hydrocarbon tails. Okay, let's see what is the hydrophobic head, which is the C, double bond, O, and OH right here, joined with this zigzag structure, which meaningly demonstrates the carbon and hydrogen bonds that we're gonna learn afterwards. Here there's the oxygen and a double bond that links it with a carbon, OH, and the zigzag hydrocarbon demonstration. Another oxygen and double bond with carbon, OH, and a zigzag. These are 3 fatty acids. That's what links it with the glycerol. It must be 3 fatty acids and 1 glycerol right here. Okay, how are they gonna form the bond between them to form a triglyceride structure? Actually, it's not that complicated. It's just the simple condensation reaction. It's a condensation reaction where a water molecule is removed. Here, as you can see, this OH with this O form the H2O that's going to be removed. It's going to be not only one condensation reaction, but a triple, or actually 3 times condensation reaction, where these are going to be removed, and this too. So these are 3 water molecules that are going to be removed in order to form this bond. Now, how am I going to show you that the triglycerides? I'm going to now rewrite the glycerol structure of the 3 carbons, but now there is only an O here, linked to an O, and here is an H, another H, and another H. Downwards is the same thing. Linked to this O is the C, and there's an O here. There's the C and another. As you can see, O, I should make that slightly here, like that. Okay, and this was where it looks like, and then the zigzag shape continues right here. This is actually what we call a triglyceride, which is definitely a type of fat. Okay, that's what we call it. And by the way, its nonpolarity is because of the absence of OH in it. there must be an OH molecule or an NH molecule or a pH molecule for us to call it a polar molecule. But actually it cannot dissolve in water. It is insoluble in water as it doesn't contain OH molecule. There was actually an OH in both of the fatty acids and the glycerol. But as a result of the condensation reaction which removed the water molecule, there is no longer any water molecule. That's why we call it a triglyceride, a nonpolar and a hydrophobic. Thank you for watching, everybody. Hope this was beneficial.